Today's topic is obviously going to be panel layouts, best practices. We're going to talk about power supply, how many you need, why you need that many, how to spec the number of power supplies that you need, and how many amps are actually going into the project. We're going to look at the terminal blocks because this is a very frequently asked question, and we want to make sure that we have the best setup or close to the best setup we have. As you can see, our panel in here was built by one of our partners, and he's done an absolutely amazing job. It looks beautiful. Everything's very neat, very tidy. But of course, as everyone else, if you really want to nitpick, we can nitpick on every single panel. So straight off the bat, I'm actually going to start from bottom to top. I'm going to close this one for now. I'm going to explain to you later. I will have it in here. But what are the first things that can be optimized? How can we improve the whole panel? And what are the first recommendations we have? So first of all, as you know, at least until config version 12.2, we were specifying in terms of power supplies at least 90% requirements, which means if, let's say we have a spot, one spot is taking roughly 7.5 watts at 100% brightness. We're specing 90% of that, so maybe 7 watts per spot. If you have 10 spots in a project, 70 watts and so on. So we're going with about 90% total consumption. What we found out is whenever we spec out to that high of an extent, we tend to have a lot of power supplies that are never getting in use. And it is something that we can quite easily test and check. If you just have a clamp meter, you can clamp it on every single circuit, you can max it out, you can see how much power we're actually using. Now, lights and music are probably going to be the two biggest consumers because, as you know, especially on the tree cable, you have the thicker cores for two reasons. One is if you have any LED strips and any compact dimmers. The other is usually for ceiling lights, spots, pendulums, anything that needs a little bit more power, a little bit more current to flow down with rest resistance down the line. Now, looking at our panel, I'm going to kind of zoom you in a little bit. And the most important bit I want to focus on for now is going to be at the bottom. So, as you can see, we have 10 amp power supplies, and we have quite a few of them in a whole panel. That is why we specified everything for 100% consumption. We also have a few smaller 1 amp power supplies in here, and also we have a few backup ones in the extension below. So the small power supplies, as you know, we usually specify them for everything that's sitting in the panel. So all the devices like the mini server, tree extensions, dimmers, everything that doesn't really require a lot of power to function, we're just using a smaller power supply. And the big ones is usually for all the spots, music, and everything else that you have in the project that might require a bit more. Now, 130 amps or 135 amps is what we specified initially. And this is exactly what we thought is going to be necessary to get everything up and running. However, after sitting down, recalculating everything, talking internally with the team and seeing what can we do to improve the whole situation, we found out 135 amps is actually never going to be used. So we had our grand opening. On our grand opening, we had a lot of lights on, different colors. We had music at a very loud level. And we've really tested out the space to see what is possible, how much energy we're actually using, and what is the maximum that a whole panel is going to be drawing. Now, this panel with 135 amps of power supplies absolutely never went above 35 amps for the total consumption of the whole space. So the first thing that we can do is obviously have a smaller panel because we don't require that many power supplies. And second, we can save a little bit of money, we can save a little bit of time when it comes to wiring the panel and getting the whole installation up and running. So because of that, I'm going to talk about the power supply and backup and how everything that you can see in here, including the 3 rows or 3.5 rows of power supplies, can be replaced with a single power supply and backup, which is, as you know, 40 amp output or 65 amp peak for a small period of time. And we're going to look at all the benefits, and I'm actually going to explain to you why that is the case. Now, how do we find out that information? Again, we have a clamp meter. If you want to, we can put a clamp meter on pretty much any single circuit, zero it out, and say, okay, how much are we pulling at the moment? Let's go to this one because it's there. So all the lights in this room, or at least one of the circuits of lights in this room, currently on about 80%, we're looking at about 2 amps. So if we keep on going, we're going to see that the same trend continues. So there's a 10 amp power supply, and we're only using about 2 amps. Why is that? It's something that I've already discussed with you last week, and I'm just going to sit down and show you before we go with the rest of the panel. So let's switch cameras again. Cool. Now I'm going to share you my screen, and we're going to look into a little bit of data. Again, please be patient with me. If you have seen it the past 2 or 3 weeks, I've been a little bit too excited to show it to you. So you might have seen more information and you already know about it. But let me explain it again for everyone who joined for today. Now I'm going to share my screen. It should, yep, should be up and running. And now let me put myself in the corner. And let's go to this. So, as you know, all the spots that you see above my head, they're 24 volt. And because they're 24 volt, they're using a PWM dimmer. And the PWM dimmer, or the way of dimming that we're using, is not linear, which means at 80% of brightness, we're not using 80% of power. At 80% of brightness, we're really using something like about 60% power. So if you never really go up to 100%, or if you go to up to 100%, that is fine. But maybe you go up to 100% in the living room and the kitchen and the reception, or some space on the ground floor, but you won't do 100% for the whole house at all time. Probably no one ever will. And to be fair, 80% is more than enough. You're not getting that much more for the last 20% that you're using. The spot is pretty much dead on in terms of what it says in a data sheet. So if you go to the web shop, go to the spot and scroll down to the data sheet and check the information. So we can kind of make a reference to start calculating how much power we're going to require for the project. You'll see product data sheet, there we go. At a maximum draw for the spots at 100%, is going to be 7.5 watts. To be fair, after measuring it out, that seems to be exactly the case. Any single spot goes to about 7.2, 7.5 watts, so very, very accurate information in here. However, when it comes to music is slightly different because, as you already know, sometimes a concern, but in this instance, I'm going to say it's a huge benefit. You all know how loud the speakers are, you know what 100% is on a Class D amplifier, but let me actually show you the chart and what we really, really have when it comes to speakers. So I'll show this to you. I'll zoom out a bit more. So we have an 8-tone speaker, and you can see percentage of total power draw at the bottom, and you can see volume on the left-hand side. If you're using just a little bit of background noise, under 10% of volume, you're barely using 10% of power. And then we can see the whole chart and how it changes. So I would say the sweet spot is probably somewhere around here, about 50 to 70% volume, because at 70% volume, we're still barely using anything when it comes to the power draw from the amplifier. So we had a test in here with the big speakers, not the ceiling speakers. And on that test, we tried to play different frequency. We tried to play through a variety of different music and see how much power can we actually draw for a single output. As you know, the output on the audio server is set at 18 watts RMS or 50 watts peak. However, whenever we were doing the testing in here, we never really managed to get to that point. The highest that we've seen is about 12 watts. And if you see 12 watts on all speakers throughout the whole installation at 100%, even that on its own, well, let's see what is the change. So let's see, 18, 12. There we go. Quite a big offset, or you can actually do it the other way around to be correct. 12. So we're only using about 66% of the maximum RMS that's on the datasheet at full power. And even if we go with the datasheet with 18 watts and we spec it out this way, we still have a lot of headroom when it comes to how much power or how much music can we play through a speaker or what volumes can we reach. Now, one thing that is important to know, a Class D amplifier running on 24 volt is not the same as a mains amplifier, an AB type of amplifier in terms of an output. So the equivalent of a 50 or 100 watt amplifier AB type compared to the audio server is not the same. They're not equal. A Class D amplifier can really output a lot of, well, the volume output is going to be very, very loud for the 18 watts that you're currently receiving, or 50 watts and so on, compared to a Class AB amplifier. So just something to keep in mind in terms of loudness level and everything else. You can see battery calculations and all of this, but I'm going to discuss it in a second. So the other thing that I really want to show you is a few changes in config that came with, I want to say, version 13.2, which is going to be released very soon as a public beta. So please feel free to mess about and see how that works. But in the project planning, we've added a few things, and we've changed a few things to make sure that we're now all at the same level, understanding why we're using 30% of power instead of 100% or instead of 90%. And I'm just going to walk you through it. So if you go inside of config, if we start a project planning session, and I'm just going to go with the default, guys. You all know how to use a project planning tool. You don't need to go through that bit. But let's say we go with the defaults. We create just a 3-bedroom house with spots, with music as a default in every single room. And now let's go to the next section. So in the next section, what we can see is we have available power, 40 amps, because now by default, the project planning tool, what it does, it has a power supply and backup. Obviously, you have all the channels being monitored. And again, when we go back to the panel, I'm going to show you why that is important. Also, every single channel, every single output is fused. So you have 7 outputs and you can fuse them to different levels. For example, if one output is going to all your peripheries, it's going to all your presence sensors and touches, you don't need to have 10 amps going on that circuit. You can limit it or you can fuse it to 2 amps. That way you have your devices being protected. And you, again, don't need that many blade fuses in the panel, but I'll show you that as well. Now we can see for my project, based on the 30% rule, or 30% power draw for the whole project, we're currently looking at 13.6 amps. So maybe the power supply and backup is a little bit of an overkill, but again, we would like to have that backup opportunity. We have to be able to see how much we're drawing in every single circuit. So it's definitely not a bad idea. Everything is going to be, all the grounds are going to be interlinked on the device. So there's you're never going to have tree communication issues because your grounds are not linked on the device or on the power supplies. And again, everything is fused and so on. So a lot of benefits. I really don't see why wouldn't we just add a power supply and backup. Maybe it's a small retrofit project. Of course, you wouldn't have one, but in a new build or a big rewire, absolutely, power supply and backup is a very reasonable choice. So as you can see, we have a lot of overheads, but how do we get to this information? So the planning tool, as soon as you add a spot, as soon as you add a little bit of LED tape, as soon as you add a speaker, it's going to take that information for the output and it's going to say, okay, a speaker has been added, 18 watts in. A spot has been added, 7.5 watts in. You just keep adding as many spots or as many speakers and channels as it needs. So if we go to the next step and finish planning, now in the parts list, we have very, very important information for you. And it's 2 sections that I really want to focus on. Yes, you have the pricing. Yes, you have the breakdown by category and rooms, but this is not the things that we care about. The first one that is very important for the panel is going to be the assignment. So in the panel, you see how many devices you have, how many you need inputs, outputs, everything that's spare, everything that you're using. In this distribution board, this is the important bits. So the planning tool is going to add every single device you need. Obviously, if you go over 8 relays, you're going to add a relay extension, same for dimmer, same for anything else, audio server, stereo extensions, and yada yada. You get the point. However, this is what we really care about. So when it comes to panels and how much space you actually need in the distribution board, this is some information that is very important for us to know. So how do I know how big of a panel would I need? Well, this is where we can find it, and we can do a little bit of estimation, or we can think about, hey, I also want to have a few more terminal blocks. I also want to have some space for future-proofing the project. Maybe I'll add another DIN rail in, but we want to overshoot by 1 or maybe half a DIN rail instead of having 5, 6 DIN rails that are just sitting in there, empty space, redundant, and you've paid a lot of money for the panel, and that customer is now thinking, okay, why do I have a panel this big when I only have like 3 rows of devices? So, for example, a small device is going to be 2 breaker units, something like a tree extension, a 1-wire extension, a KNX extension, anything else. Mini server, audio server, dimmer is going to be 9 breaker units of space. And usually, if you go with a panel from, let's say, Future Automation, or if you go to any panel of a similar size, you're going to have about 27 breaker units of space, which means that you can have 2 big devices, so maybe a mini server and a dimmer extension, and then you can have 2 smaller extensions, maybe a tree extension on top and an air base just for your air devices. Now, based on that information, we can see how much space we need in terms of millimeters of space, and we can also see the total space in breaker units. The space in breaker units is probably going to be a better breakdown. Again, you can do that on your own and say, okay, a power supply and backup is going to be 18 breaker units. And it's also going to dissipate a lot of heat because it's a power supply at the end of the day. It's a transformer. And maybe I want to have it on its own DIN rail, don't have any extensions next to it. Absolutely fine. Especially when we talk about separating the mains and 24 volts, which we'll look into in a second. Now, with power supply and backup, that's 1 DIN rail. Stereo extensions, you can fit quite a lot on a single rail. You can fit 10, 12, 13, absolutely fine with the number that we have in here. Mini servers. So it's going to combine all of that information. It's going to let me know, okay, I need 51 breaker units of space. I'm going to need 902 mils. Now, you can do a very simple calculation. And let's say that one of your DIN rails can fit 27 breaker units of space or 27 breaker units worth of devices. So you can say 51 divided by 27, which is going to give you 1.8. So 2 DIN rails are going to be enough in a bigger panel. However, if we start thinking about terminal blocks and maybe a little bit of heat dissipation, you can start seeing where you can add a second rail or maybe a few terminal blocks. And if you want to have the power supply and backup on its own rail and nothing nearby on the left or the right-hand side, maybe we're talking about 4 DIN rails. But 4 is still very reasonable for a big project, 5, 6, 7 bedroom house, or in a commercial project like ours, where we have 38 speakers, we have a lot of spots, we have pretty much whole singing or dancing project with everything that you can imagine. So taking that information, we can do the calculations our way. Cool. But the new tab that's been added to the parts list whenever it's generated is that very last one, is the power usage. And the power usage is super important. So if you scroll down, you can see it's broken down in different sections. You have all the devices, have the power supply and backup in here, that kind of pokes in the eye. We have controls. So your air base, your tree extension, your dimmers, your RS-232 extensions, Modbus, anything in that panel that is an extension or a control device, we're going to have in here in its own category. And as you know, mini server consumes less than 3 watts. The tree extension and the air base, they barely consume anything, like 0.1 watts. We're talking about a very minuscule amount. but these are the important bits. So for the controls, yes, you can have a separate circuit, or you can have a circuit with maybe a 1 amp or 2 amp fuse. So make sure you protect the device a little bit more. And that is exactly what we have in terms of breaking down the categories in different sections. But the big one is going to be lighting and music. The music, obviously, these speakers need to be powered. We have our amplifier, and even though it's not using as much as a lot of different amplifiers on the market, it's still using something, and we need to take that into account. And you can see, okay, a single spot is 7.5 watts. We have 27 in the project, and it's going to do the calculation for us, which is going to be 200 watts. Absolutely fine. Same with an audio server, 162 watts, almost 3 extensions, 120 watts per one, or 480 watts for the whole device. Now, again, this is us being a bit conservative, but you can keep on going for any LED tapes, anything else that you have in that project. And as you can see, in terms of controls, in terms of the mini server, in terms of all the extensions, we take it 100% of that value, because let's be honest, 3 watts, 10 watts, that is not going to break the bank. It's not going to be that much different. You just need a single output or a single channel, a single power supply to be able to power all of them at the same time. But when it comes to music and lights, even if you have the alarm going off, everything's flashing on, off, all the music, all the alarm sirens, everything, let's say 50% or 80% volume, we're still not going to tap in that 100% power usage. And we can say, okay, take 30% of the required power, and this is the output, 328 watts. Now, in here, I've done an example with a 3-bedroom house, but you can see still for a 3-bedroom house, that is definitely not a lot. For example, if you have just a normal lighting panel, you've seen them, mains powered on, off. One of these can easily be 56 watts on its own. So 6 panels is going to give it that whole project. So you're not going to have music, you're going to have spots. You're just going to have 6 panels in the room, and it's going to be the equivalent of this. And again, peripheries is going to be the very last one. We can see peripheries, so all our presence sensors, the touches, any now to relay trees, or the small device, again, that don't really consume a lot of power. You can see that information we're just taking at 100%, because we also want to account for things like voltage drop. So maybe if you have your valve actuators on a very, very long run of tree cable, you'll need to have them at 30%, or you want to have a little bit of wiggle room on top. That's why we're going at 100% power. And now we can see at the end of the day, the whole project, we're looking at 352 watts. And if we put this one in the calculator, 352 divided by 24 volt, we're looking at 14 amps for the whole project. If we go with 100%, you can see this is going to quite quickly double, triple, and quadruple. But we have quite a few projects. We're talking from experience. We're not talking just because we've measured it once with our own panel. When it comes to our quality management, when it comes to everyone that's working in the hardware team, they have locks in their own houses, and they've seen a few instances where you have a big 40 amp power supply that's sitting in there, redundant, never been used, never going to be used, because they absolutely never switch everything on at 100%. Maybe switch everything on 100% in a room at a time, but overall, you don't need to. Another cool thing in config is that when it comes to the biggest argument is usually, what if I have an alarm system and that my alarm system is going off at 100%, and now I trip the whole system, or the mini server goes offline, or the device go offline. That is not really going to be a problem, because both on the lighting controller, on the alarm blocks, and on the devices itself, we do have, as you go to audio player as well, we do have limitations that we can set. For example, on the lighting controller, if we scroll down, you can see minimum, maximum brightness, and so on, alarm flashing interval brightness, and all of this. In the alarm blocks, you do have all the values that you need, alarm modes, alarm durations. So you do have the full adjustment to tell, okay, I do not want to have all the lights on at a 50%. So maximum brightness for the alarm. I don't want to have it at 50%, I maybe want to have it at 40%. But keep in mind again, it's exponential. So even if you have the alarm on for the entire house at 50% brightness, 50% brightness is only going to correlate to about 30-35% of power usage. So even if we drop this one down to maybe let's say 40%, we can still have the alarm flashing in the entire house. It's going to be absolutely fine. Same with the music, because that's even more exponential, and that graph that we've seen earlier, it's even more drastic in terms of changes. We can just decrease the volume for the alarm and say, okay, I don't want it to be 50%, I maybe want it to be even 70%. Again, 70% is going to be more enough. You're gonna trip anything. If you want for like your own peace of mind, have a little bit of wiggle room, that's absolutely fine. But don't have 100 amps worth of wiggle room, have maybe 10, 20, just so you're peaceful and you know maybe in the future, if I want to add a few more lights, if I want to add a few LED strips, I'm not going to be desperate for power and you need to buy another power supply. I have enough on board already. Okay, enough rumbling, enough config. Let's go back to the panel and let's see what else can we do to improve it and what recommendations we have. I'll change cameras again. Let me here. And also, sorry Martin for taking time to respond. I've just now seen it. Is installation pelved or self? I'm going to discuss that in a second. So I'll stop the screen share before anything. Thank you, Kieran. So now installation. Let's actually move a bit closer. And a few things we want to talk about. Don't know how well you can see. Hope you can see it well. Now, yes, that is correct. The PSU supports both PELF and self installations, but let me go to that point first. So, in here, we'll be able to see at the bottom, we have a 20 nerve coming into the power supply. On the top, we have the 24-volt side. So, mains in, 24-volt out. Why is that important and what can we do with that information? So what we want to have is we want to have a nice separation between our mains and 24-volt side. So for example, in here, whenever we have mains coming in, they're coming from the bottom, and from here all the way up to the top, we do have that separation happening. So if you have all your 24 volts going on one side and all your mains going on the other, you have less interferences, less chance of anything going wrong or having communication issues on either channel. Now, is the installation PELF or self? Again, it depends. You can argue for both. So self-installation is a little better, a little bit safer. However, our installation is deliberately PELF. Why? Because of music. So if you have any ground references when it comes to the line in or a line out. So let's say I have my projector. My projector has a line in connected to the audio server. The audio server is always also obviously connected to the whole system. The whole system has connection to mains. And now we have created what is called a ground loop. Without ground loop, what is happening is it introduces a lot of huss or a lot of noise. So two ways to approach it. You can deliberately PELF your installation, or what you can do is you can grab a ground loop isolator, and that isolator is going to act for you and is going to kind of reduce the huss because you're going to have a reference, or it's going to tap away the reference from the earth. Or if your projector or AV receiver does not have an earth pin, that's also another way to do it. The power supply in the background. Again, can be both. Yep, we both, and all of that we can also go through data sheets. And well, I can also show you in a bit. So, one of the things that are very, very important. Let me go even closer. I hope it's not too blown out. Okay, somewhat good. So, the first good things that we can see is obviously the 24-volt. We're going with the locks and colors, and we have the 1.5 mil tree cable in, which is absolutely correct. You have your orange for the plus and white for the minus. Keeping the colors the same, everything's good, so everything's consistent. Then, as you can see, they have ferrules. So because these ones are stranded core, this is a stranded core cable. Because of that, you always want to have a ferrule, especially in a screw-in terminal block or a screw-in Phoenix, like this one is. Now, from here, we're going up and we start going to different devices. Let me go with a few recommendations of things that we can do and improve. Now, obviously, you can have the separation between your music and audio. Sorry, between the mini server and devices and audio server. That's absolutely fine. I'll actually recommend doing it this way. However, if you start going up the panel, you can see, okay, mini servers here, extension here. The very, very last extension does have 120 ohm resistor. I don't know if you can see. There we go. Which you should always have at end of line. At the very top, we do have our terminal blocks. And what's important about the terminal blocks, what is important about the space overall. So first, we'll do it like this. So first information that we need to know, we have different types of terminal blocks. If you go with our terminal blocks, obviously, we have the blues, which are one-to-one connections. So whatever you put from one side is going to come from the other. We have the grays, which are interlinked on the inside. So all of these are linked together. We have the fused ones, and we obviously have the twin nerves in here. Now, what is important to know? These are clamp connectors. So they have a release mechanism, they clamp on the insides. So that is why you do not want to have ferrules on them. Now, in this situation, I do want to say it's obviously done because of consistency. It's not a big deal, but overall, you do want to have just a stranded core, or you want a solid core to go directly into the clamp connector, because wherever you go directly into the clamp connector, you have a bigger surface area which you can clamp on, so it creates a better connection. So maybe ferrules are not going to be the best idea in here. Also, as you can see, we have quite a few connected to our tree cable for communication. So we have the white and green, obviously going down to the tree extension and all of the tree branches. However, you can see we only have, let's say, two connections in the back. So what can we do? We're going to remove the whole block of terminals, and instead of doing this, we can go directly on top of the tree extension, because the tree extension or the push-in connector already has 4 inputs. So because we only have 2 outgoing connections, we could have saved ourselves a bit of money and a bit of space in the panel, just going directly on top of the extensions. Now, keep in mind that every single project you can improve something. So it's not just this one, it's every single project where we can do it differently. Why this one is done this way, for example, I would say again, nothing bad, especially for how our partner works in his installations, because what he wants to do is he wants to create a panel off-site, which we do understand. Isn't that lovely? I mean, everyone would like to create a panel in the office and then just let everyone know, or let the electrician on site know where they need to connect the incoming cables to, and that is it, job done. However, if you want space, save time and money, maybe that's a recommendation we can go with. Now, exactly the same. I'll say this is a much better use of the terminal blocks, because you can see, obviously, we have all the 24 volts going out, and this is going to be for the periphery devices. So every single presence sensor, tree, nano 2 relay trees, everything else we have. And we obviously have the power supply coming from the bottom. But maybe what's going to be better in here is to have a smaller power supply or have a blade fuse in place, because if this circuit is fused, we're going to have a little bit more protection for that small for the small devices. Then next to it, what we have is we have our grounds all interlinked. You can see from one extension to the next. This is absolutely perfect. I do like the way it's done. And again, we do have all the grounds coming from the other side to our devices. Obviously, what this is doing is linking the grounds between the different power supplies. Why is that important? Well, I'm pretty sure that all of you can tell me, instead of it being the other way around. But why is that information important? Because if you have a potential difference between different circuits, let's say you have two power supplies and the grounds are not linked, you can have up to 48 volts going on that circuit. So we can damage devices, we can over voltage devices. That's why it's super important to connect all your grounds. Now, going to the next section. We have the blade fuses. So this is for our lights. So for example, if I pull one of these fuses, I don't know if it's the third one or the fourth one, but let's see. Yeah, it's this one. I pulled it off. And what happened in the room that I'm currently in, the very last circuit of lights switched off. So now I can safely go ahead, and if I need to do some work on that circuit, I can. And also, obviously, everything's fused. So I do have my backup in place. And as soon as I push it in, there we go. Connections back in. Perfect. Now, the only thing that I can say about this one is that we have them fused, but we have them fused with 10 amp fuses. Well, we already have them connected to 10 amp power supplies, which means that in our case, it's not as necessary. Again, it's a good idea, just in case, for whatever reason, we output more than 10 amps from any of the supplies. However, you shouldn't have to. You have a 10 amp power supply, you have a 10 amp fuse. The power supply is going to do the protection on its own. Now, something else when it comes to terminal blocks, and that might be more me than anyone else. However, when it comes to speakers, you always want to make sure you have a nice quality cable. So usually low oxygen copper, and you want to make sure that you have the thick enough cable depending on the depending on the distance between the amplifier and the speaker itself. And also you want to make sure it's uninterrupted. So because of this, I would actually advise for us to do something else. So as you can see in our case, we do have the outputs for the speakers coming into this terminal block. And then from this terminal block, they're going out to every single speaker. Now, in here, we are breaking the connection, even though it should still be a solid connection because of the clamp on the inside. We would actually prefer to have just a straight signal between the amplifier and the speaker directly. So that is also another reason why I can absolutely recommend for us, instead of going with the audio server on the second and third row, I'll actually have it higher up, because that way we can remove, oh, that's very bright. We can remove the terminals, saving money, saving space. And also, if you have the audio server higher and the stereo extensions higher, what you can do is you can route them directly out of the panel, and then shorter distance plus easier for you to cable because you don't have all the cables coming from one place and one direction. So that is going to be the shortest path, obviously, and it's going to be uninterrupted by any switches or any terminal extensions. Now, again, not a bad practice if you want to do the whole panel at home and you want to let someone else wire it up, because you're just going to let them know to which number or which panel the things need to go to. Now, next, or pretty much the last thing in this panel to look into would be the 20 nerve blocks. As you can see, you have a 20 nerve in here doing exactly what it's doing. You have live, neutral, and the earth in the back. That is a perfect example of how we can do it. And then we also have the connections on the output side of the mini server out of the 20 nerve. So everything that we're switching when it comes to mains power, 12-volt power, anything else, is just going out through the 20 nerves directly. That's absolutely fine. I can only recommend kind of a setup. Now, one more thing, as always, because I won't have one in here. As you know, the pushing connectors on the mini server or the pushing connectors on the audio server, any other device that we have, they're made for solid cores, and they're made for solid cores only. Plus, you can break them if you keep pushing in and out cables, or if the cable is far too thick. Now, that is why I have one more recommendation. As you can see, these cables also have ferrules on them, but that is a solid core cable. So we actually don't need to have a ferrule on it. We can just go directly into the pushing connector, and that is going to be better for the device, better for the connector, and overall, we don't necessarily need to spend time putting ferrules on everything that we want. For stranded cable, yes, absolutely. So something like the outputs on the audio server or stereo extensions, especially in the screw and terminal, yes, ferrules are absolutely perfect. But for a solid core cable, maybe we just leave it as it is and we push it directly into the device. Now, the very last thing that we have in our panel is going to be the extension on the bottom. The extension on the bottom is super, super simple. There isn't too much going on, but you'll be able to see we have a few additional power supplies, and we have our breakers for different circuits. So if you need to override the system, or if you need to test something, you can just slap one of the breakers, cut the power that's going to the power supply, and work on it directly this way. Now, I'm going to leave this open. I'm going to go back to the laptop, and we'll point out a few different things, or how we're going to be able to improve that panel as soon as we have the power supply and backup. Actually, first of all, let's just do a side-by-side comparison and maybe talk about it a little bit more, because it's an exciting topic in general. Okay, that's perfect. So, power supply and backup, 18 breaker units of space, or for better visualization, it's 2 mini servers. So if you have 2 mini servers back to back, this is how big the device is going to be. Now, this is what actually is going to replace all of our power supplies. So instead of having 130 amps, we're just going to have 40 amps of power supplies. That is going to go most likely in the bottom if we're being lazy, or maybe we can push it all the way up to the top because of heat dissipation. As you can see, remove the power supplies here, remove the smaller power supplies, slap one power supply and back up. We're still going to have that nice separation between our mains and the 24-volt outputs that are going out, because you have mains in, 7 fused 24-volt outputs. You no longer need the blade fuses on top because every single output is going to be fused, and you can fuse different channels with different fuses, obviously. So, for example, in here you can have your mini server extensions. In here you can have your peripheries, so presence sensors, touches, and then we can talk about lights, music, and whatever you need. And of course, the benefit of the battery is always in here. And it's a true device for communication. So side-by-side comparison, if I slap it in, or maybe in here so you can better visualize it, that is going to get rid of 2 DIN rails because of the fused in terminals. We're also going to get rid of quite a few terminal blocks on the top. Well, that is very, very blown out. A few terminal blocks on the top, and overall that panel is, well, it's not going to be reduced in size by half, but we're definitely going to have 1 DIN rail, which is kind of just sitting in there, and we'll be able to have a little bit more room for any future products that come to us, and we'll be able to install them in our project without thinking, oh no, where I'm going to fit it, I don't have enough space. So again, absolutely beautiful panel. I'll be very, very happy if I see anyone do a panel of this size, this scale, to such a good finish. So please take it with a grain of salt. We don't really want to go in the panel and say, oh, this is everything that's bad with it. It's absolutely a great one, but as always, things can be improved. If we go with our recommendations, before we knew about a power supply and backup, before we knew about 30%, or before we started implementing the 30%, this is exactly what the panel was going to look like. So it's on us as much as everyone else. I'm going to switch around again, and I'm going to hopefully be able to answer a few questions on your side, guys. So, yeah. Okay. Let's see. So, Martin. Panels, yes, they are. Assembly unit requires yes. In cables into device directly would not. Well, because we're talking about low voltage devices, or actually extra low voltage devices, when it comes to especially tree communications or the tree protocols, so for example, just replacing a few of the outputs, a few of the terminal blocks and just going direct to the outputs, especially for the communication protocol, that's absolutely fine. You can do it with Modbus, you can do it with Tree, you can do it with RS485. So that shouldn't be a problem. On the power side and the main side, a bit more important, yes, as you said, we do need to satisfy requirements. And I want to just take that time. So any questions and answers, guys, anything that comes to mind, or maybe any recommendations that you have on your side? So with the reduced load calculation on new power supply and backup, you can potentially get rid of a lot of the power supplies and blade fuses. Yes, absolutely. So because of the new recommendations, going with 30% instead of 90, we don't need as many power supplies as we currently have, because this, or the 135, we calculated with 100% load. So we wanted to make sure, okay, this is our showroom space. This has to be the best of the best. It has to show to every single customer that walks in what is possible. And that is why we spec'd it to 100% load. However, this is going to be more than adequate. And again, the blade fuse is on top. We do not require, because every single channel is going to be fused in here already. And that should be more than enough. Does a power supply and backup have built-in surge protection? Yes, the same as any of the TDK lambdas that we have on the wall. So even the 10 amp TDK lambdas or the smaller TDK lambdas do have surge protection in. A 14 amp power supply and back holder. Can I change the back? I wouldn't say no to that. I mean, absolutely. If you want to, we can speak tomorrow, or just drop me an email and we're gonna get it sorted. Do you know what type of surge? Unfortunately, I'm not 100% certain about what the maximum amp surge is. I know it can take up to 65 amps for a short period of time, but for some of the devices, for example, let's say a dimmer, it's much higher than that initial 65 for, let's say, 5 or 10 seconds. It can actually take a little bit more. Surge protection and should shut off the device. The device is going to restart, reboot, and come back to normal operation. So completely honest, my side, I would say 65 for a small period of time, and then we go shorter term. Yes. There we go, 10 seconds, 60, not 65. So that. But again, with some devices, it's not information that is out there publicly, but there is a higher number we can use. Anything else? Any concerns, possibly? No search for vehicle. Yep. That is correct. I'll have to check and go back to you with this one, but we'll definitely do to just make sure that the device is obviously certified to the law you think about. But if we go with what we currently know, it's going to be very, very similar to what we already have in terms of the TDK lambdas that we're using. It's going to be up to the same standard of power supply, so it shouldn't be an issue. Anyone else? I do have to show you one more thing before I forget. So, not this. Let's go to that. We'll probably need dedicated sage device as well. I mean, we did see the breakers on the bottom, and that is also going to give you a little bit more protection than just the device itself on the 24-volt side. Specs of the battery required for the backup facility. Where do you specify the battery required? So if we go directly to the power supply and backup, there it is. For a data sheet. There we go. 36-volt battery, lead acid 1, and you can see discharge, nominal, discharge peak, and the maximum current charge. Great. That is the information for the battery. And again, as a recommendation on our side, we're not going directly with like a 36-volt battery, which you can find like in a boat. We are talking more about having 3 12-volt car batteries because they're the most common one in the market to find. And just whatever the amp hours is you need for your project, kind of specify that in. Because in terms of discharge rate and maximum charging current, we're still looking about the same pace, or actually much lower when it comes to the car battery. Okay. In the meantime, if anyone comes with any questions, feel free. But what I wanted to share is obviously the poll for end of training, because we are very, very thankful. So obviously all of you for participating, and I do want to share that with you. There we go. Share this, get me out of the way, and let's see. So live demo, we've already done this. Well, let's switch the poll on, launch it, and the poll is very simple. We do have 50% off again from update training. It's going to be the same for every single webinar. So if you want to grab the next one, feel free. However, we do have 2 training dates. The last one for the year, the 14th of December, or we have the first one of next year, which is going to be the 12th of January, already added in. So feel free to grab either date, or if you've already done update training, for example, I've met Martin the other weekend here, you don't need to schedule anything, obviously. On the 8th of December, what's coming is designing, installing, and configuring TouchPure Flex. We've moved it a little bit earlier. You'll find out why later. And on the 15th of December, for the very last webinar of the year, we're going to have planning, designing, Lockson project for hospitality. So whenever it comes for a bigger project or using stuff like the multiplicator, which came out this year, well, multiplicator is going to be the best example. TouchPure Flex is going to be a good example. So it's kind of going to prepare us for that session. And to register for the next webinar, let me do the same as we did in here. It's going to be the same link for every single week. You can just go to en.info-partners-webinar and register for the event. I can also drop it in the chat. So, why that? Give me 30. Hey guys. Technology. www.auction.com/en/info@partner webinar. So you can grab the link, you can register for next week, and we're good to go. And of course, as every single time, thank you very much for joining and tuning in, watching the whole webinar. I really, really do appreciate you guys. I'd love to see you in here and love to see you all participate. Actually, we have Paul raising a hand. Paul, feel free. Before I was going to shut it off. Have questions? Will be shipped from the UK warehouse now. Lead time, yes. And when the one wiring terminal works. One wire. Sorry, that these are 2 different chats, but one wire you can do a star. You can do a daisy chain, because one wire is working on 5-volt protocol, or the protocol itself is working on 5-volt communication. Voltage drop is something to be somewhat concerned with. So when it comes to daisy chaining one wire sensors, it's going to be best to is going to be the best kind of performer. If we're talking about setting up doing a star or spraying off, yes, you can do that, or you can go direct to the device. So every single one wire can be running back. Depending on that information, you either increase or decrease the range. The other one was, will it be shipped from the UK warehouse? No. What is the lead time? Oh, sorry. Okay. What is the lead time? The lead time is actually going to be the same, but you can also grab the availability spreadsheet to check the latest updates. Our warehouse manager, Luke, updates them pretty much every single Monday. So we should have the latest information in there as well. But as you can see, I have one in my hand, so it wouldn't be that further down the line when you can grab a power supply and backup and have it in your installation.